Yeah, hi guys. Now we are going to move towards our third chapter. Like you already remember, we have just completed our chapter 2, in which we had discussed polynomials, right? So we are going to follow up with that. We are going to move with forward with our algebraic portion. So this is another part here. This is coordinate geometry. The word coordinate is vastly used. You guys should be knowing its meaning, what its meaning is. I will be explaining you the accurate meaning of this term, although you guys will be familiar with this term. So what we are going to do today, we are going to start with the chapter 3. Remember, we are going to start with the chapter 3. So this is quite an easy chapter. I think this chapter might be finished up in just one sitting. That means around, you will be taking around 50 to 60 minutes, or you can say 1 hour, approximate 1 hour to finish up this entire chapter. See, this chapter goes deeply in your class 10, but for your class 9, it is not that much deep here. You guys will be known to some familiar things. You guys will be remembering most of the things from earlier classes. There will be some new things or just new concepts here. So you guys will be remembering majority of the portion that you have just covered in your class 8. You had done that graphs portion, right? It was in your class 8, I guess 15 to 16 chapter. So that we will picking up from there. I will be moving on now, and we will be now dealing with two dimensions here. Remember, till your class 10, you are going to be dealing with only two dimensions. While you move on to your class 11 and 12, you guys will be having three dimensions, or you can say your 3D geometry. So remember, for now, you just have your coordinate geometry. It is a two-dimensional geometry. So we are going to learn everything that this chapter has to offer. Its practical applications, how we use coordinate geometry, and what everything that is related to that. So remember, this chapter is not lengthy. This might end up with this video only, and we will be having practice session tomorrow. So remember, you have to make the proper notes of this chapter because they are not lengthy, and notes will also be available on our website also. If you want to take them from there, you can just take them by joining that, or you can do what, you can write each and everything with me. I'm writing in front of you. So let's start with this chapter. So bring that pen and notebook with you. So let's start with this video now. So before we get to the point, let's just go back to brief history of coordinate geometry. So actually we just focus on Descartes. Actually his full name was René Descartes. He was a French mathematician. He was actually everything that we are going to study in this chapter, typically a Cartesian plane. Everything that you are going to learn today actually is based on his theory. But what happened here was there were two mathematicians that were involved with this chapter. Descartes got famous because he got everything in written, although he was participating in that. But Fermat was also interested in this. Actually, there happened what Descartes thought of plotting the points, or he was just doing what, he was just sitting in his room, he was lying down, and a thought struck his mind that what should be the actual point or the position of an object with respect to other. Let's say if you're sitting in your room and you want to just figure out the point where your fan is with respect to you. So you guys will be doing what? You guys will be measuring the distance between you and the fan, the vertical distance, and the distance between the nearest wall to that fan. Actually, while you're sitting in your room, that is not a case of two-dimensional geometry. That is actually three-dimensional geometry, since you will be dealing with what? You will be having lengths, your breadths, and your vertical heights, right? If I just typically draw a corner of your room, it should be looking like this one, right? If you look at this, that is your what? You can call this one your length, this one your breadth, and this one is your height. So you guys see the point where all three lines are meeting, all three dimensions are meeting. That is what? That is your origin, right? This is the case of three-dimensional geometry. But let's say we are not going towards there. I am just doing what Descartes thought what? He was just lying down. He looked at some object there. Then he thought, what would be the distance of that object from from his particular point? So whatever that distance was, he just thought of that as a coordinate system. Later we got our Cartesian plane, in which we were dealing with two dimensions or three dimensions. We are going to study that later on. So his theory, along with the theory of Fermat, we went on having our two-dimensional geometry and three-dimensional geometry. Now in our present times, we are using each and everything related, we are using coordinate geometry in each and everything. Almost everything now is actually based on your three-dimensional geometry or a two-dimensional geometry. We will be studying the applications. So I will be just giving a quick example here. You guys use Google Maps also, right? So you guys do what? You guys just enter an address and you guys just get a direction to that place, right? You can just move along that direction and you can reach your destination, right? But sometimes you guys see if that address is not properly loaded onto your maps, you guys will be having some coordinates here, or you can say longitudes and latitudes here. You guys remember your SSGO, right? There are grids, right? Each and every grid is following what? That is the portion between a particular latitude and longitude, right? So everything is plotted on the globe, and that has coordinates with respect to their longitudinal axis and their latitudinal axis. So actually that theory is based on our Cartesian plane. So we are going to study this one. So see, let's just go back to this and just read it out. So system was developed in 1637 and written by Descartes and independently by Faraday Fermat. Fermat worked in three-dimensional, but he did not publish his theory or his discovery. Both authors use single axes in their treatments and have variable lengths, measure the difference of the axes. Actually, did what they were not just going on with two or more than two dimensions. Initially, they thought of just one dimension. That means you guys see he was lying down and he just observed an object. So distance between him and that object, that was what? That was actually the axis that they were considering. Later we got two various axes. Now we have three axes in 3 dimension and two axes in a 2 dimension, right? So I'm going to move forward with this. So let's start with the first let's have a look at them. So this guy right here, this picture that you can see, this is Faraday Fermat, right? And this guy right here, you can see this is René Descartes. He lived from 1601 to 1665 and he lived from 1596 to 1650. So these are the guys that are actually, you can say, the founder or the fathers of your coordinate geometry, specifically this man right here. Now we are going to move forward and start with the introduction. So coordinate geometry is what? Coordinate geometry, or the system of coordinate geometry, it is what? It is the points on number line that are put at equal intervals. They can be having more than one, they can be see, if I do what? They are generally what? They are the positions of an object with respect to their distances, the vertical and horizontal distance. If you plot them together, you will be getting a line. That line is what? That is your number line, and you can say that will be your coordinate geometry, that will be your Cartesian plane there. So see, it is what? Coordinate geometry of the system of it has been derived from the correspondence of points on number line and real numbers. See, I will be explaining it later on. Just remember this. Everything that you can plot on a graph that has a finite value, that is a point, and the number lines that you are going to use to represent those values with respect to their x-axis and with respect to their y-axis, that will be a coordinate geometry, and the plane that in which the points will be lying, that will be a coordinate plane, or you can say a Cartesian plane in this case. So it includes a horizontal line. You guys see, if I had drawn the graph here, it had this horizontal line and it had one vertical line. See, on the number line, you mostly will be having your real numbers. There cannot be any imaginary number. You guys see, imaginary numbers are not represented on number lines, right? You guys remember that from your chapter 1. So it will be having any possible real number on it. You can represent a square root 2, square root 3. Your irrationals, you can represent your rationals also. 2 by 3, 3 by 4, 5 by 6, etc. Anything you can represent on number line, it has to be a real number. So remember, anything that can be represented on number line, that will become a part of coordinate axis. If you have a vertical line number line there and a horizontal number line here, between both of the number lines, or you can say your axis, you will be having an angle of 90 degree, or you can say both of the horizontal and vertical number lines will be perpendicular to each other, and the point where they intersect each other, in our case the initial point of every number line, that will be 0 0, and it will be termed as our origin. You guys see, if I just draw a number line representing group of integers, so you guys see, in the middle I will be having a 0, on the right hand side I will be having every positive number, and on the left hand side of 0 I will be having any negative number, right? You guys remember, this is from your class 9, sorry, your chapter 1, obviously from class 9. You guys should be knowing this initially from class your 5th also. Now if I do what? If I just draw a vertical line here, now you guys see, if I just tilt this over, if I just represent this vertically, now you guys see, above of 0 every value will be positive, and below of 0 every value will be negative. So this is what? This is 0 again. So you guys see, your vertical axis right here, if I just pick it up and drop it here, so I will be getting this coordinate plane, or you can say a Cartesian plane, in which the point where both of their zeros coincide, that point will be origin, its value will be 0 0. On the left hand side of 0 you will be having every negative value horizontally, and on the right hand side of 0 you will be having every positive value of your number line, right? So this is what we have here. Now I'm going to move forward and see coordinate plane, or your Cartesian plane. See, we are dealing with two-dimensional geometry. So you guys see, we have two axes here, an x-axis and y-axis. They are at right angles to each other. You guys remember this? So your vertical axis, if you just have this vertical one, this is your y-axis, and if you have your horizontal axis, that is your x-axis, right? Singular is axis and plural is axis. So just pronunciation is totally upon you, but remember this is axis and this is axis. As in, if you plural this x, you guys remember that x, right? The plural of that will be axis. So these are the horizontal and vertical distances. I will be having this explanation later on. I will be considering a proper slide there, and I will be explaining each and everything to you. Just remember, coordinate plane will be having two axes, your vertical and horizontal. Horizontal axis will be your x-axis and vertical axis will be your y-axis. Now I'm going to define your x-axis and y-axis here. So you guys see, x-axis is what? Again, I told you the horizontal axis, horizontal scale is called your x-axis. As you go right from scale 0, you will be having all positive values here in your graph right here. You guys see, if you're moving towards your right hand side, you guys see the gap is of 5 at each interval and you have only positive values on the right. But if you move on to the left, you will be having all negative values here. Gap is still the same, it is of -5 on each side, each interval. Now you guys see another name of your x-axis. Keep in mind, this is asked in your exams, this can be asked, this has been asked also. The another name for your x-axis is abscissa. If they have given you that the value of abscissa is, let's say, 5, what they truly mean is that value of x is what? It is 5. Similarly, if you have your vertical scale, your vertical number line, that is your y-axis. As you go upwards from 0, you will be having positive values. As you go downwards, you will be having negative values. And another name for your y-axis, that is what? That is ordinate. So always remember, abscissa is x and ordinate is y. Okay, that is the point here. You guys should be noting this one. Abscissa is x and ordinate is y. So I will be explaining the concept of quadrants also. So remember, most of the time you will be given something like this. It's plot a point whose abscissa is 3 and ordinate is 4. So what they truly mean is value of x is 3 in that case and value of y is 4. This is the meaning of your abscissa and ordinate. Remember, both are what? Abscissa is x and ordinate is y. So you guys see, as you move upward, y will be positive. As you move downward, y will be negative. As you go towards right, x will be positive. As you go towards left, x will be negative. So that is the point that we have to learn till here. Now let's move forward and see what do we have. So origin, you guys already remember this. The point where two axes cross, or you can say where their origin, their initial, where their 0 coincides, that point will be origin. At origin, the value of x is 0 and value of y is 0. So you guys see, this is the case here. And quadrants are what? These are the 4 parts in which your coordinate plane is divided. So I will be explaining them and I will be giving you some hints here to guess where the point will be lying, in which quadrant will that be lying. So let's just come back to the explanation here. So you guys see, you have been told that we have 2 number lines. Let's just have our horizontal scale right here. In the middle, I will be having 0, and on the right hand side, every positive value, right? And on the left hand side, we will be having every negative value, right? And we have another scale which is vertical scale. See, that is the case here. In the middle of that, let's say this is the point which is 0. Above 0, every positive value is there, and below 0, every negative value is there. Now we are going to do what? I'm going to pick this one and put it there. So while I plot these 2 lines of scales together, each of them is perpendicular to another one. So you guys see, I get this coordinate plane, or you can say your Cartesian plane, in which we have what? This angle is 90 right here. At this point is what? This point is your origin. You guys see, this will be what? This will be your 0, 0 point. That means I will be explaining this one. So just wait a second. Let me just do everything else. On the right hand side, it will be positive value of x, right? So I'm going to write it here, x positive. Okay. On the left hand side, x will be negative. So let's just write it like this. Upwards, this is y will be positive, and downwards, y will be negative. Now you guys see what this means. This means, if you just break it down, always remember, while you have been given a point, you will be having x first and then y. You will always be plotting your length first, then your breadth, or you can say your height. In our 2-dimensional case, this will be length and this will be breadth. So you will always be plotting length first and then breadth. So what this truly means, what does 0 and 0 mean? It means that the distance of this point from x-axis, it is what? It is 0. That means our point O, it has two coordinates 0 and 0. Our first one is x and our second one is y. This means that this point is lying at a distance of 0 units from x-axis and 0 units from y-axis. That means this point is lying at the middle of the two lines. So you guys see its coordinates will be what? 0, 0. Now if you are getting confused here, let's just consider this one. We have an x which is 3 and a y which is 4. We have to plot this point. The point which will be having its axis are 3 and y to be a 4. So firstly, let's just draw our number line here. I'm going to consider our equal space here of 1 units. So let's say this is our 1, this is our 2, this is our 3, and this is our 4. Now you guys see my x is positive and y is also positive. So x positive is on the right and y positive is towards upwards. So 1, 2, that one 3, and this one 4. Now you guys see this means that a point which is 3 units from x-axis. So you guys see 3 units from x-axis. That will be what? 3 is here. So you guys see this will be the line right here. I don't know what is that, but I need to plot a line which is x equal to 3. So let's say this is the point 3. Line will be passing through this point, right? And I need to have a y which is equal to 4. Y4 is here. I'm going to do what? I'm going to extend this line. Wherever both of these lines meet, they meet at this point. So you guys see this is the point right here, which is what? 4 units upwards and 3 units on the right. This will be the case. So x equals to 3. Actually, I'm telling you the opposite one. This is what? This is a distance of, actually I was telling you the distance from x-axis. It is actually a distance from origin. So you guys see there will be a point, let's say this is the point P, which is 3 units from the origin, or it is at the third position on x-axis. So you guys see this will be what? This is the distance of 3 units, right? So P point is right here. I'm going to do what? I'm going to just extend a line right here. Now you guys see I need to have a point y equals to 4. This is y units from the origin. You guys see y units upwards. So you guys see if I just mark this one point here, this is here. Let's say this is point Q. If I just draw a line passing through this point, both of the lines are intersecting at, let's say, this point R. It will be having the coordinate 3, 4, where this is your x and this is your y. So actually x equals to 3 is what? It is the distance of 3 units from origin. In that case where we were talking about origins, so remember in that case we are going to deal with 0 and 0. So distance from 0, distance of x which is 0 from your origin, that will be there, and distance of y which is 0 from origin, that will be there. So it will be the initial point. So always remember, while you are dealing with points, you have to find out the distance from your origin. Now let's just move forward and let's plot another point. Let's say I have been given this -3, 2. I have been given this point. You have to do what? You have to look for, firstly remember this is your x and this is your y. So you have to look for a point, or you have to look for a point at on x-axis which will be -3. So guys, see if I just plot it here, this is -3, that will be on the left hand side. So this will be what? A -1, a -2, and a -3. So you guys see I have to plot a point which is on x-axis at -3. I got it here. Or you can say the distance from origin should be -3. So I will be moving towards the left hand side. So this will be the point. I will be doing what? I will be drawing a rough line here. Let's say a line which is passing through this point. This is x equals to -3, right? Now I have to look for a y which should be 2, or you can say 2 units above your origin. So that will be what? 1, and that will be 2. So this will be the point right here. If I just move forward, if I just draw a line here, so you guys see this is y equals to 2. So wherever both of the lines are meeting, that point will be what? Our required point, which will be -3, 2. So this is the point here, right? Now let's see if I just erase this, and let's just understand the concept of quadrants now. So see, quadrants are what? Quadrants mean 4 parts. Quad means 4 and rants means part. So we are going to do what? While we intersect two lines horizontally and vertically, we have 4 parts right here. See, this is our first quadrant, this is our second, this is our third, and this is our fourth. Counterclockwise, first, second, third, and fourth. Like I see, initially we have this origin right here, right? This is 0, 0. On the right hand side, x is positive. On the left hand side, x is negative. Upwards, y is positive, and downwards, y is negative. Now guys, see, in our first quadrant, x is positive and y is positive. So if you have been given a coordinate or a point, both of whose values are positive, let's say a comma b, that point will be lying in your quadrant first. So they can ask you, in which quadrant will point 3 comma 4 lie? So you guys see both of the points are positive, both of the values are positive. So you guys see this has to lie in what? It has to lie in your quadrant first. Now in your second quadrant, you guys see your x is negative and y is positive. So your x will be negative, that means it will be like this, a negative a and a b. So if your x is negative and y is positive, if you have something like this, minus 3 comma 2, and they have asked you in which quadrant would that be, so you guys will be telling that we have x negative and we have y positive, this has to lie in our quadrant. Now come back to your third one. You guys see x is negative and y is negative. In this area you have x negative and y negative, so it will be what? It will be like this. If I just erase this, it will be like this, a negative a and a negative b. So if you have something like this, negative 3 comma negative 2, then you guys automatically will be thinking that both x and y are negative, they have to lie in third quadrant. And finally you guys see x is positive here, so you will be having a positive a, but you will be having a negative b. So if you have something like this, 3 comma minus 4, you guys see x is positive and y is negative, it has to lie in what? It has to lie in your fourth quadrant. And always remember, the vertical distance from origin, see this distance, that will give you your y-axis, and the horizontal distance from origin, that will give you your x value, right? And wherever both of the lines meet, that point will be actually your coordinate that you are going to plot. So everything that you have learned up till now, that is the explanation here. Now let's move forward and see what do we have. So applications of your coordinate geometry, I have already told you that your globe is divided into your grids, and you plot each and everything using your longitudinal and latitudinal value. So guys see, this is the point here, longitude and latitude values. You can just plot each and everything using your values there. So that is actually your coordinate system. That is practical here. Now you can also use that one in your movie theaters also. You guys see, you have been given your movie tickets, and in that you have been written something like this, A5, B6, C11. So what they truly mean is that in your A row, that means this one, you have your fifth seat. So you guys see A is here, fifth seat is here. Your seat is actually this one. If you move to B6, you guys see that will be your second row, and you will be having the sixth seat right here. In C11, you will be having a third row, and your seat will be 11, right this. So they have plotted each and everything like this. You can just understand this one, and you can find your seats easily. So this is the point right here. I hope you guys understand this, right? So it is used in the movie theaters also. It is used in your maps also. You guys remember 3D mapping, 3D models. You guys see what happens here is, while you're drawing blueprint of anything, or you are, let's say an architect is there, he just does what? He does a 3D model of a house that is going to build, or building that is going to build. He uses what? He using 3 dimensions there. With every miniature dimension, he is going to compare the actual building that is going to be built later on, but he will be showing you a model in which everything will be present, but that should be in your miniature size. So he is using what? He is using coordinate geometry also there. So that is the point here. So now we are up to the questions here. So we have to write the coordinates of each point in this. So you guys see, you guys remember the vertical distance is what? It is your y, and horizontal distance is what? It is your x. So you guys see, there is a point which is negative 3 units from your origin. So you guys see, x here is what? It is negative 3. So its x will be what? Negative 3, right? And its y is what? Vertical distance is 4. So its coordinates are what? Negative 3 comma 4. So coordinates of m, that will be what? Negative 3 comma 4. Easy. Now in B case, see, horizontal distance is your x, it is what? It is 4. So for B, your x is 4, and y is what? Vertical distance is 3. So that will be what? That will be 3 here. Now for the case of S, now you guys see, horizontal distance is 3 and vertical distance is negative 4. So for case of S, your coordinates are what? 3 comma negative 4, right? Because you are moving downwards, your y will be negative. I hope you guys understand that, right? So let me just erase this and write it neatly. So there should be a 3 here, right? Now for the case of L, you guys see, it is what? Horizontal distance is negative 5 and vertical distance is negative 4. So for case of L, that will be what? That will be negative 5 comma negative 4, right? Now what to do if I just erase this, and let's see, if there is something like this, if they have given you a point, if they have given you a coordinate which is like this, 2 comma 0, where will this point be lying? So you guys see, its x is 2, its y is 0. So you guys see, your vertical distance from origin is what? It is 0. So that should be here. And you guys see, your horizontal distance is what? It is 2. So the point should be this one. Remember, if you have been given any x's, let's say x is 0, and you have been given a value of y, let's say it is a, and your coordinates are like this, 0 comma a, that point will lie on y-axis. If you have been given any coordinate in which y is 0, but you have been given any value of x, let's say it is a, and coordinate is like this, a comma 0, that point will always be on x-axis. Remember, this is not truly mean, it does not mean that it will be on the positive side. If the value is negative, then it can be on negative side. But what I want to tell you that if there is any value of x available, but there is no value of y available, and you're going to plot that point, always remember that point will be lying on axis. Or you can say, if one axis is given to you that it is 0, then the point will be lying to its opposite axis. Right here, our x was 0, our point will be on y-axis. Our y is 0, our point will be on x-axis. So remember, this is the point that you have to understand. If you have been given any x is 0, the point will be lying on your another axis. If you have been given like that, so it is the case here. So let me just erase this and quickly ask you a question based on our earlier concept. So you guys see, if they had only given you, let's say they had given you a coordinate 3 comma 6. So if they had asked you where will this point be lying, in which quadrant will that be? So you guys see, your x is positive, your y is positive, that will be what? That will be here. If they had asked you where minus 5 comma minus 4 was, then you guys see both of them were negative and it should be here. So this is how you can guess the point in which quadrant will that be, and you can easily plot that point. Just to remember, x is the horizontal distance from origin and y is the vertical distance from origin. I hope you guys understand this. Now let's move forward and see what do we have now. So we have exercise 3.2 right here. This is the second exercise. In our first exercise, it is quite easy. You can just do that on your own. So you have this one. What is the name of horizontal and the vertical lines drawn to determine the position of any point in Cartesian plane? So what are the names of horizontal and vertical lines? They are x-axis and y-axis, or you can say your abscissa and coordinate, right? What is the name of each part of the plane formed by two lines? What is the name of this part right here? See, it is telling you that there are two lines, which is like let's say this is one and that is the one. What is the name of the plane between these two lines? So what is the name of the plane between this x and y part here? This will be what? This will be a quadrant, right? Then write the names of the point where these two lines intersect. Where do they intersect? They intersect at origin, right? So it will be what? It will be origin. So your answers are these. I hope you guys were able to answer them on your own. Now let's see. We have our second part right here. It is this one. In figure 3.14, that means this one. The coordinates of B. What are the coordinates of B? You can easily answer this one. B is what? B is here. You guys see, B is negative 5 on the left hand side and positive 2 vertically. So this should be what? This will be negative 5 comma 2. Now coordinates of C. B are negative 5 downwards and positive 5 horizontally. So towards right and below, that will be what? 5 comma negative 5. Value of x is 5 and value of y is negative 5. Now point identified by the coordinates minus 3 comma 5. So you guys see, minus 3 is negative, actually the x-axis is negative, value of x is negative and value of y is also negative. So it should be lying in your fourth quadrant. So one of these 2 points, h and d, that will be the that will be having that coordinate. Now guys see, horizontal distance should be negative 3 and vertical distance will be what? Vertical distance will be 5. See, this is your x and this is y. Horizontal 3, vertical 5. So you guys see, horizontal 3, this one, vertical 5, this one. Horizontal 3, vertical 5. So it will be this one. That means our point will be what? It will be point. I hope you guys understand this. So this will be what? E. Now point identified as 2 comma minus 4. Now you guys see, x is positive, y is negative. So we will be where? We will be in the fourth quadrant, right? X positive, y negative. So vertical distance should be negative 4 and horizontal 2. Horizontal 2, vertical negative 4. So it should be what? It should be G. Now abscissa of D. Abscissa means x. X of D. Where is D? D is here. What is the value of x here? It is 6. You guys see it is 6. Coordinate of h, where is h? H is here. What is the vertical distance? It is -3. Now, coordinates of point L, where is the point L? It is here. So you guys see it is lying on your y-axis, and I've told you already, when a point is lying on x-axis, that means its other axis is 0. That means in this case, x is what? X is 0, and value of y is what? Y is actually 5. It is 5 units vertically upwards. So coordinates of L will be what? X is 0, y is 5. It is what? 0, 5. And coordinates of point M, where is point M? Let me just erase this. See, I can see the point M is here. This is right here. So you guys see what will be the coordinate of M. M is lying on x-axis right here. So you guys see at x-axis y is 0. So that means it will be having y as 0. And its horizontal distance is what? It is -3 units. So it will be what? -3, 0. So these are the answers. I hope you guys were able to get each and every answer correct on your own. Now I'm going to move forward and let's finish up with this chapter, because that is what we are going to do today. This is quite easy. Now we are going to plot the points right here. You guys already remember how to plot those points. So you have to do what? You have to draw your graph, right? Let's draw this one. So you guys see what is the maximum value of x that you can see. X is 5 here, x is 2 here, x is 5 here, -3, -3 and a 5, and a maximum 6. So horizontally we should have 6 units. 1, 2, 3, 4, 5, and this one 6. And what is the maximum value of y and minimum value of y also? Let's see, the maximum I can see is of 5. Do we have anything else? Of 5 again, and minimum is -5, right? So 1, 2, 3, 4 and a 5. You guys should be doing this one on a graph paper, so you guys will be doing more neatly than me. So you guys see this will be -1, this will be -2, and minimum value of x is -3. So this will be -3. And for the case of y, -1, -2, -3, -4 and a -5. So you guys see our first coordinate is what? It is 5, 0. You guys see we have x, we don't have any y. So that means this point will be lying on axis. So you guys see horizontal distance 5, that should be here. We don't have any y, so that means it will be this point. So this is point, let's say A, which is 5, 0. Now we have 0, 5. You guys see x is 0, y is 5. So it should be here. Vertical distance is 5, horizontal distance is not there. So it will be what? Let's say this is point B, which is 0, 5. Easy. Now let's move forward and see with this one. 2, 5. Horizontal distance 2. This is the horizontal distance, and vertical distance 5. So you guys see this is the value of x right here. If I just draw the line, that will be the case. And this is the case here. So this will be what? Your vertical distance is 5. They are meeting at this point. This point will be what? Let's say this is point C, and that is what? 2, 5. And then you have what? 5, 2. Its horizontal distance is 5 and vertical distance is 2. Horizontal distance 5 is right here. Let's just draw a line here. And vertical distance is 2. So let's say this is the point. So where they meet here. This point is D, which is 5, 2. Then we have horizontal distance -3 and vertical distance 5. -3 is here, vertical 5, that is here. So that point should be lying somewhere here, considering this is the line and that is the line. So this will be what? Let's say this is point E, which is -3, 5. Then we have -3, -5. Now you guys see both of them are negative. They will be lying in third quadrant. So -3 here and -5 here. So your point will be this one. Let's say this is point F, which is -3, -5. So you guys see, you can use this one, but it will not be healthy practice. So always try to just plot the points directly rather using lines. But you can use them. Use dotted line in such scenarios. Now you have a horizontal distance 5 and vertical distance -3. So you guys see 5 is here, -3 is here. So that means they will be intersecting somewhere here. This point will be your, let's say, G point, which is 5, -3. And lastly 6, 1. Maximum value 6 and 1. That should be the point. It should be somewhere here. And this will be what? This will be your H point, which is what? 6, 1. So this is how you are going to plot each and every point on your graph. You can easily plot them in your Cartesian plane on your graph. So always try to use graph while plotting them, or you can just draw them in your notebooks. But in exam, you have to use your graphs. So remember, if you are plotting each and everything on graph, that will be quite neat and tidy to look at. So always try to use this one. I hope you guys understand plotting scenario. Now let's see what do we have next. So we have to plot this one. This is quite easy also. So draw the graph again. So I can see the maximum value of y is what? It is 7 and minimum value of y is negative 3.5. Now you guys see we are dealing with decimals also, and the maximum value of x is 4 and minimum value is minus 3. So you guys see you can either go with the gap of 2 units each, or you can just plot them using your 1 centimeter scale. Since I'm short on space, so I'm going to do what? I'm going to just write them tightly. So let's say this is the origin 0, 0, 1, 2, 3 and a 4. 1, 2, 3, 4, 5, 6 and a 7. Similarly 1, 2, 3 and a 4. That will be negative here, and in this case negative 1 and a negative 2, right? Negative 1, negative 2. And this is 1, 2, 3, 4, 5, 6 and 7. This is 1, 2, 3 and 4. This is minus 1, minus 2, minus 3 and minus 4. Now guys, see your first coordinate. You have to write them together like this. So it is negative 3, 7. A point where x is negative 3 and a point where vertical distance is 7. So you guys see a negative 3 here. So negative 3 is your horizontal distance. Vertical distance is 7. So that point should be intersecting somewhere here. So that will be a point A, and this is negative 3, 7. Similarly 0, 3.5, you guys see this is 0. That means the point will be lying only on x-axis and this value is negative. So it will be in the middle of these two. Let me just change the ink here and let's plot it with black one. So this will be the point right here, this point. Let's say this is the point B, and that will be what? 0, negative 3.5. Then we have what? We have minus 1, minus 3. X is minus 1, that should be here. Y is minus 3, that should be here. Together they will be intersecting at this point. This is the point, which is our C point. This is minus 1, minus 3. Then you have 4, 4. 4 is here. Horizontal 4 and vertical 4. Both of them will intersect here. That will be the point D. This is 4, 4. And lastly 2, minus 2. 2 is here and sorry minus 3 and minus 3 is here. Point will be intersecting somewhere here. This is the point E, which is 2, minus 3. So I hope you guys are able to plot them. If you are unable to, then just use the lines. Let them intersect each other at one point. That point will be the coordinate that you have to plot. So guys, see, they have told you that you have to use the scale of 1 centimeter or 1 unit. You have to use it like this. But if they have not mentioned to you that, you have to use this scale. So you can take a scale of 2 units or 2 centimeters each, like this. You can plot 0, then 2, then 4 in multiples of 2. You can draw your graph like this also. But keep in mind, if you are using this scale in your x-axis, then you have to follow up with this scale in your y-axis. You cannot just alternate the scales on both axes. That is not healthy. You have to use each scale with each axis. That scale will be same. Either it will be of 1 centimeter or 1 unit, or it can be of 2 units. So remember, that will be the case here. Now let's see, what do we have? So we have your final exercise 3.3, in which we have to do what? You guys see in which quadrant will they lie. You guys see what you have to just tell them in which quadrant will they be lying. So you guys see you have what? A negative x and a positive y. So you guys see negative a and positive b. That was what? That was the case of second quadrant. So it will be what? Let's just do what? I'm going to write it here. First, if that is first quadrant, I'm going to highlight that with, let's say, blue. Okay. If that is second quadrant, I'm going to highlight it with yellow. If that is third quadrant, let's just choose one more color and let's say light green. So let's say green. If it is fourth, I'm going to leave it. So you guys see it was what? It was our second quadrant. So that should be what? Highlighted with yellow. So that is the case here. Sorry, I've just used pen there. That should be highlighter. That will be the point, right? Now we have a positive x and a negative y. So you guys see where will that be lying? If I just plot it here, the graph in front of you, this is the positive x and this is a negative y. So this will be in the fourth quadrant. So it should be left as it is. So I'm not gonna highlight this. Now again you have what? A negative x and a positive. You guys see this is what? This is something like this. If I just use the pen, you guys see. You have what? You have a negative x and a 0. Now you guys see this will be lying where? You don't have any y value here, so it should be lying on your x-axis. So it will be what? It will be on x axis, right? You have to just plot the axis here. So this will be on x-axis. Now next you have what? 1 and 2. You guys see both of them are positive. So they will be lying where? They will be lying in your first quadrant, and that should be highlighted with blue. You guys see, this will be what? They will be in your which quadrant? Your first quadrant, right? So that will be what? That will be blue. And lastly, you have both negative, and that will be lying in your which quadrant? That will be lying in your third quadrant. So this will be green. So I hope you guys understand this and you don't have any doubt in this case, right? So quite easy. So in short, this was second, this was fourth, this was x-axis, this was first quadrant, and that was third quadrant. I hope you guys get each and everything, right? And then you have to verify them. You can just plot them on your own and you can verify them later on. Now let's see, what do we have next? Plot the points which are these, and we have to plot them on table and use the suitable units. Now guys, see, your maximum value of x is what? It is 8, and the minimum value is 0.125, which is negative. You can easily plot them. That is the case here. You can just draw the graph and plot them on your own. So you have to do this. This is quite easy. And with this, we have just completed our chapter 3 also. Tomorrow we will be having what? Our doubt sessions, and you can say I will be having some practice questions for you guys. We will be following up with that case, and then we will be starting. I think we should start our lines and angles. That chapter is quite interesting, and you guys will be paying more attention to that. So I think we will be picking up with chapter 6. And if there is any other thing than that, I will let you know. You can just check out our website. That will be published here. But for now, this will be the case. So let's just quickly revise each and everything. So summary for today. You guys understood what are positions of an object with respect to another one. You just understood their x values and their y values with respect to their horizontal distances and their vertical distances. So we use our two axes in such scenarios, x and y, right? That plane in which we plot each and everything, that was what? That was a Cartesian plane, or you can say a coordinate plane. It had two axes for this chapter, but we are dealing with 3-dimension geometry. You are having 3D plane, then it will be having 3 axes there. So we had two axes in this chapter, which were what? Our horizontal line, that was our x-axis, and a vertical line, that was our y-axis. The coordinate axis divided into 4 quadrants, right? The lines were dividing when you intersected both of the lines. Your plane was divided into 4 parts, that each part was your quadrant. So in first quadrant, you had what? Both of the values are positive, your x and y. In second, x was negative, but y was positive, right? In third, both x and y, they both were negative, and in fourth, x was positive and y was negative. Now guys, see the points where both of the axes intersected. That point was origin, and its value was 0, 0. And you had what? See, the distance of point from y-axis, or you can say origin, that was what? That was your x coordinate, that was your abscissa, and vertical distance, that was your y coordinate, or you can say your coordinate. If you wanted to plot the entire point, then you have to consider that from your y-axis, or you can do what? You can just plot your x. See, if you had something like this, 2, 3, it meant there is a point 2, which is 2 units from origin on the right hand side, and we had a point 3, which was 3 units from origin upward side. So you can either plot them, let them intersect each other. That point will be what? That point will be the coordinate that you need, right? Then you had these. If you had an axis 0, if there was no value of that axis given in that coordinate, that means that axis was 0. The point will be lying on its opposite axis. If x was 0, point will be on y-axis. If y was 0, then x will be on, if y was 0, x will be on, point will be on x-axis. If x was 0, point will be on y-axis. Now you guys see, this is what we have learned today, and you guys see, these are the things that we had to plot. Now in one more case, our 11th part, I guess we didn't study this one. So you guys see, if you have something like this, generally this, I will be explaining this in your chapter 4 while we are dealing with the linear equations in 2 variables. There we will be learning more about this one, but just remember, if you have been given that x is equal to y, then you have to plot this line. Always remember, your line will be passing through origin like this. If x is equal to y, you can see, if x is 0, then y is 0, so it will be at the center. If x is negative, if y is negative 1, then x will be negative 1. Let's say this is negative 1 and that is negative 1, it will be here. Then if x is negative 2 and y is negative 2, then x will be negative 2. That point will be here. So you guys see your equation, or your line on your Cartesian plane, that will be passing through the origin, and that will be a straight line. You guys see, this will be like this. So we are going to study this one in a chapter 11, and for now these are the 10 points that you have to keep in mind while you're dealing with your coordinate geometry. If we are going to study a chapter 4, I'll let you know, but most probably we are going to start with our lines and angles, then we are going to pick a chapter 4. Till then, study as much as you can. You have just completed a chapter 3, so you have to practice each and everything. These 3 chapters were very easy, but you have to pay more attention to them. I'll see you in the next part. Till then, just remember, you have to practice more. So bye for now. I'll see you in the next session. Okay, bye for now.